Hi, 8th graders. We're going to wrap up this Jack and Jill lesson with activity 2.5. So, real quickly, just want to summarize some things from this lesson. You've discovered that the equation y equals mx represents a proportional relationship. The equation represents every point, x and y, on the graph of a line with slope m that passes through the origin 0, 0. So, this first paragraph represents a proportional relationship. The second paragraph talks about a non-proportional relationship. So an equation of the form y equals mx plus b, where b is not equal to 0, represents a non-proportional relationship. This equation represents every point xy on the graph of a line with slope m that passes through the point 0, b. So this non-proportional relationship describes a linear relationship, but not proportional because it does not pass through the origin. Now, for the rest of this activity, I would like for you to try all of these problems completely on your own before you watch the rest of this video. If you want, you could complete problem number 1 on your own, unpause the video and check answers for problem number 1 only, complete problem number 2, check your answer for number 2, complete problem number 3, check answers for number 3, and then likewise with number 4. Complete number 4 on your own, then unpause the video to check answers. But I would really like for you to try to do this independently. This is kind of a summary and practice for this lesson with proportional relationships and linear relationships and finding slope. So this would be a great time to pause the video and come back and check answers. For problem number 1, it said determine whether the graph represents a proportional or non-proportional relationship. So let's do that first. This graph would be a non-proportional relationship. The reason is it does not go through the origin. So we're going to write an equation in this form, because this is the form of a non-proportional relationship, to represent the two quantities. So for this, I need to know the slope, which is vertical change over horizontal change. And I also need to know what b is. B is the starting point. Since it's not through the origin, I know it's not 0. So the starting point is probably the easiest one to determine. So in this case, we're starting at 20 on the y-axis. So we know b is equal to 20. For slope, we need to determine the vertical change from this point to this point, or you could use this point to this point. It does not matter. So vertical change would mean how far do I move up? I like to consider this kind of like a game of Pac-Man. I move up vertically and then horizontally. So how far did I go up? I was at 20, now I'm at 28. So I moved up 8 units. How far did I move horizontally? Well, I was at 0, and then this point is at 60 horizontally. So that puts me 60 units is the difference here. So the slope, the vertical change was 8. The horizontal change was 60. So our slope would be 8 over 60, or we could simplify that to 2/15. Now that we know m and we know b, we can substitute them into this equation. Y equals mx plus b. So our slope was 2 over 15 x plus b was 20. So the equation for this graph would be y equals 2/15 x plus 20. For part B, we would determine that this graph is proportional. It's a line, it goes through the origin. So for the second part, we know we're writing it in this form. We just need to determine the slope. So again, 0, 0 is 1 point. If we find another point on this graph, so it looks like we could use this one. That looks like it's 160 over 2.5. Let's see if there's another one instead of that decimal for 2.5. So right here looks like a good one. This would be 5 hours, 320 miles. So I could draw that triangle again, like I drew earlier. So I could see how far I went vertically, how far I went horizontally. Vertically, I was at 0. Now I'm at 320. So that's a distance of 320. Horizontally, I was at 0. And now I'm over at 5. So that's a distance of 5. So my slope is vertical change over horizontal change. If I simplify that, so if I do that division, I get 64. So the equation would be y equals mx, and if m is 64, the equation for b would be y equals 64x. Hoping you're having some success with this. Would be important to share this with me if you are having some issues or some struggles. On C, I should be able to determine this is non-proportional, does not go through the origin, which means I'm going to write the equation in this form. So I need to know M, I need to know B. B is the easy one, that's the starting point. We're at 30 up here on the y-axis. Slope, I need vertical change over horizontal change. So here's a good starting point. I need another point here. So I don't think it quite goes through that lattice point. Right here, I think it does go through this point. So I'm going to do my triangle right here. 30 to 39, that's a distance of 9 units. And then this is from 0 to 7, a distance of 7 units. So my vertical change was 9, my horizontal change was 7. And I'm going to leave it improper just as 9 over 7. So now I take this form of the equation. I replace m with 9/7 and b with 30 for y equals 9/7 x plus 30. For number 2, determine the slope of this graph, write an equation to represent it. All right, so slope of this graph. Again, if I have 2 points, I need vertical change over horizontal change. Well, the vertical change, I don't have to move at all. The vertical change is 0. Between these 2 points, that was a distance of 3. 0 over 3 is 0. So the slope of this is 0. I do notice it's starting at 5. So b is 5. My slope is 0. So my equation, go up here, would follow this form. If the slope is 0, that means 0x plus 5 for b. So 0x is nothing. So my equation would just be y equals 5. Situation that could be modeled by this. What's happening is that time is going on, but the number of miles is staying the same. So this could be a situation where my car is parked at school 5 miles away from my house, and it's parked there all day long. So it's just staying 5 miles away, even though time is going on. Number 3, complete the table of values to represent the linear relationship specified, then write an equation. So this is a proportional relationship. So we look at where we have a y quantity and an x quantity. So we have 12 and we have 2. So we need to figure out what the constant rate is here, what the constant ratio in this table is. If it's proportional, there is a constant ratio. So we know one ratio is 12 over 2. So if we simplify that ratio, that would simplify to 6 over 1, or just 6. So I know when x is 1, y would be 6. I also know that since it's proportional, it goes through the origin. So this would be 0, 0. And then 1, 6. And then 2, 12. 3 would be 18 because I multiply the 6 by 3. When x is 4, I could multiply the 6 by 4. Or I could use the ratio it's supposed to be in order to figure out the y coordinate here. I could do a proportion. 1 times x is x, 6 times 4 is 24. Solve it using cross products, just another way to do it. So there's the table. The equation then, if this is k or m, the first slope, then my equation for a proportional relationship follows this. So my equation would be y equals 6x. For the letter B, this time it is non-proportional. Non-proportional. So all that matters is that I am still increasing by the same rate. So I'm still going up by the same amount from one point to another. So it doesn't really matter where I start as long as I increase by the same amount. So just as an example, I'm going to start at 2, and then let's go up by 5, I think will work. So from 2 to 2 plus 5 is 7, 7 plus 5 is 12, 12 plus 5 is 17, 17 plus 5 is 22. So the rate, the increase is the same every time. I'm increasing by 5, so that's my slope. But I'm not starting at the origin. I am starting at 2 instead of the origin. So the equation would not be this. It would be plus b, since this is not 0. And I would have y equals 5x plus 2. Non-proportional relationship here. All right, so wrapping it up. Draw a line through the point and label the graph to represent the linear relationship specified, then write an equation. So we have to draw a proportional relationship through this point. So through that point, I know it also has to go through the origin if it is proportional. So I'm going to start at the origin and go through that point, and I'll end up right there. If it's proportional, then I know it's going to follow y equals kx or y equals mx. I just need to find the slope. So again, vertical change over horizontal change. That vertical change was 10. The horizontal change, we went from 0 to 6. That's 6. So my slope is going to be 10 over 6, which simplifies to 5 over 3. So it'd be y equals 5 thirds x. For b, this time it's non-proportional. Non-proportional. So I can, all that means is my line's not going to go through the origin. So I'm just going to put it right here. I'm going to start up here at 4 and go through that point. There we go. So I know it's non-proportional. That means it's going to follow this form. I need to know m, and I need to know b. B is going to be 4. That's where it starts. My slope, I can do a triangle here for that. So this was 4 to 10. That would be 6 units. And then I went over 6 units also. So my slope would be 6 over 6, which just simplifies to 1. So here are the two things I need for my equation. Y would equal 1x plus 4. Anytime you have a 1 as a coefficient, you can just get rid of it and just say it's x plus 4. So y equals x plus 4. And that is a fantastic summary of this lesson with proportional relationships, non-proportional relationships, slope, and the equations that accompany proportional and non-proportional relationships. Please let me know if you had any trouble with any of those. Those are certainly things that we would want to go over again. So have a great day, everyone.